Hello everyone, today I am presenting our paper towards LLM-based failure localization in production scale networks. My name is Xavier Saran, and this work represents a collaboration between Alibaba Cloud and Nanjing University. We have built a system called Bayan. It is an intelligent assistant designed to solve one of the hardest problems in cloud computing, figuring out exactly which device broke when the network goes down. Let's start with the problem. Imagine you're operating a global cloud network with millions of customers. When a major incident happens, it is not just a single red light blinking, it is an avalanche of data. A single incident can generate over 1 gigabyte of text logs. For a human operator, finding the root cause in that mess is likely finding a needle in a digital haystack, but the pressure is enormous. In this industry, downtime is expensive. It can cost up to 1 million per hour. Every second spent reading logs is money lost. So, how do we handle this today? If you look at the left side of the screen, you see the current reality. We have automated tools that self-heal about 90% of simple issues, but the remaining 10% are the complex, high-risk incidents. These get passed to human operators. This creates a human bottleneck. Operators have to manually read through thousands of lines of logs under extreme stress. It is slow and it is easy to make mistakes. On the right side, you see our solution, Bayan. Bayan acts as an AI-powered assistant. It automates the heavy lifting, reading, and reasoning so the human expert can make the final decision instantly. But we couldn't just feed 1 gigabyte of logs into ChatGPT and hope for the best. It would be too slow and too expensive. Instead, Bayan uses a hierarchical reasoning. It divides the problem into 2 stages. In stage 1, we use smaller, faster LLMs to look at every device individually. They summarize the noise and ask simple questions. Is this router congested? Is the link flopping? Then, in stage 2, a more powerful model takes those summaries and looks at the big picture to find a root cause. To do that global reasoning effectively, Bayan needs context. An error in a network spread like a virus, so just looking at error logs isn't enough. Bayan triangulates the truth using 3 specific data pipelines. Alert data. This tells us the symptom what went wrong. Network topology. This tells us how devices are connected. If a parent router fails, all its children will scream. Bayan knows to blame the parent, not the children. And last, event timeline. This tells us who failed first. The timeline is critical for understanding cause and effect. Now, a common question we get is, network change every day, won't the AI model get outdated? Training a large language model is expensive and slow. We cannot retrain it every week. Instead, Bayan uses a continuous prompt updating loop. When Bayan solves a case whether it was right or wrong, it reflects on the results. It extracts knowledge from that experience and updates its own instructions, its prompt. It effectively trains the prompt rather than the model parameters. This allows Bayan to adapt to new configurations almost instantly. So, does it actually work? We deployed Bayan in Alibaba's cloud's production network for 10 months. The results were excellent, as you can see on the charts. Bayan achieved a 95.5 accuracy in locating the error device compared to just 86 for our existing baseline tools. Most importantly, it reduced the time to find the root cause by 20.5% overall, and for the most dangerous, high-risk incidents, it was 55% faster. Operators also reported that they trust the system because Bayan explained why it chose a specific device. To conclude, Bayan transformed the needle in a haystack problem into a streamlined workflow. By combining log analysis, topology, and timeline data, we empower operators to maintain the high reliability that cloud customers expect. We believe this approach using LLM as reasoning assistant is the future of network operations. Thank you so much.